Okay, my dear children, yesterday we have discussed some concepts, chain rule, the derivative of a composite functions. After that, we have started sums in exercise 5.2. I have explained the first two questions of exercise 5.2. Okay, my dear children, you try the question number 3. Same as that of question number 1. Question number 3 is same that of question number 1. Okay, my dear children. Now I am explaining question number 4. Question number 4. Differentiate secant of tan root x. Secant of tan root x with respect to x. We have to differentiate this function with respect to x. So let us consider y is equal to secant of tan root x. For the first two questions also, we considered the given function as y. So here also we are assuming that the given function is y. Understood this step, my dear children? Right. Now, differentiating with respect to x. Differentiating with respect to x. I said many times, this sentence can be written in the short form like this. This is the short form of this full sentence. D dot W dot R dot T dot X. In the upcoming exercises, we use this short form to denote this full sentence differentiating with respect to x. Okay, my dear children, remember this point. This implies d by dx. What is the differential operator? D by dx, because we are differentiating the functions on both sides with respect to x. That is why d by dx is the differential operator. So we are writing the differential operator on both sides. Understood this step, my dear children? Right. In LHS, what will you get? D by dx of y, dy by dx. In LHS, we get dy by dx. Now come to RHS. This is a composite function of secant x, tan x and root x. This is a combination of three functions. What is the first function? Secant x. Consider this entire function as x in your mind. Next, tan x. Consider this entire function as x in your mind. So first we use d by dx of secant x. Okay, my dear children, don't confuse here. So what is the formula for d by dx of secant x? Secant x into tan x. So secant, what is x here? This entire function, that entire function is considered as x in your mind. Remember that point. So secant of tan root x into tan of tan root x. I wrote d by dx of secant x formula. Secant x into tan x. Understood this part, my dear children? Into d by dx of tan root x. Because we assumed this entire function as x in your mind, so we have to differentiate that function. Understood this part, my dear children? Understood this one also, my dear children? So I am writing here formula d by dx of secant x, d by dx of secant x is equal to secant x into tan x. I wrote d by dx of secant x formula, that is equal to secant x into tan x. Understood, my dear children? Right. Now we write this part as it is, because that is over. That part is over. So secant of tan root x into tan of tan root x. And again come to this differentiation, d by dx of tan root x, d by dx of tan root x, d by dx of tan root x. Again I told you here tan x, it is in the form of d by dx of tan x, it is in the form of d by dx of tan x. Consider this root x as x in your mind. Remember this point, my dear children, don't confuse. So d by dx of tan x, what is the formula? Secant square x. So secant square, what is x here? That root x is assumed as x in your mind. Okay, my dear children, understood this part? Secant square of root x into d by dx of root x, because we assumed here root x as x in your mind, so we have to differentiate that part. Understood this part, my dear children? Right. This is equal to secant of tan root x into tan of tan root x into secant square of root x. And come to the last part, d by dx of root x. I gave the list of derivatives of some standard functions. In that list, this formula is also there, d by dx of root x. What is the formula? 1 by 2 root x. 1 by 2 root x. So differentiation part is over, because I am writing here formula d by dx of root x is equal to d by dx of root x is equal to 1 by 2 root x. So differentiation part is over. So just we write the given function in a particular order. This is equal to secant of tan root x into tan of tan root x into secant square of root x whole divided by root x. Understood, my dear children? Understood this stuff, my dear children? Right. This is the derivative of the given function with respect to x. Okay, my dear children? Right. Now come to the question number 5. Question number 5. Differentiate sin of ax plus b by cos of cx plus d with respect to x. We have to differentiate this entire function with respect to x. Understood the question, my dear children? Right. So I told you for the previous questions we follow the same steps here also. Let us consider given function is y. So y is equal to sin of ax plus b by cos of cx plus d. Understood this step, my dear children? Right. Now we differentiate with respect to x on both sides. Differentiating with respect to x. This implies d by dx of y is equal to d by dx of sin of ax plus b by cos of cx plus d. I wrote here differential operator. Remember this point, my dear children. Differential operator is here dx, because we are differentiating with respect to x. Okay, my dear children? Right. Now in LHS, d by dx of y, what do you get here? dy by dx. Now come to RHS part. It is in the form of d by dx of f of x by g of x, u by v rule. In class 11 you have applied u by v whole dash, d by dx of u by v formula. So here is u, this is v, or this is f of x, this is g of x. So what is the formula? G of x. So cos of cx plus d into d by dx of sine of ax plus b g of x into d by dx of f of x minus g of x sine of ax plus b into d by dx of cos of g of x into d by dx of f of x minus f of x into d by dx of g of x whole divided by g of x whole square. G of x whole square. Here I write the formula d by dx of d by dx of f of x by g of x is equal to g of x into d by dx of f of x minus f of x into d by dx of g of x whole divided by g of x whole square. This is the formula. I applied this formula here. Understood this step, my dear children? Right. Now come to the next step. We come to the next step. In RHS only we simplify. That LHS we leave that LHS as it is dy by dx. Now this is equal to cos of cx plus d into, now it is in the form of d by dx of sin x. It is also a composite function of sin x and ax plus b. It is a composite function of sin x and ax plus b. So first we use d by dx of sin x formula. We consider this entire function within the brackets as x in your mind. Okay, my dear children. So d by dx of sin x formula. We apply that formula here. What is the formula? Cos of ax plus b into d by dx of ax plus b. D by dx of sin x. What is the formula? Cos x. X means here ax plus b only, not x. Remember that point, my dear children. Into d by dx of ax plus b, because we assumed that function as x in your mind. So we have to differentiate that function. Understood that part, my dear children? Minus sine of ax plus b into d by dx of, this is also a composite function of cos x and cx plus d. It is a composite function of cos x and cx plus d. So we have to apply first d by dx of cos x. Consider that entire function within the small brackets as x in your mind. Okay, my children. So into minus d by dx of cos x. D by dx of cos x means minus sin x into d by dx of cx plus d, because we assumed here cx plus d as x in your mind. Understood that part, my children? Whole divided by cos of cx plus d whole square can be written as cos square of cx plus d. Understood this part, my dear children? In the denominator, right. This is equal to, we write this part as it is, cos of ax plus b into cos of cx plus d. Cos of just I am rearranging that terms. Cos of ax plus b I wrote it first into cos of cx plus d into, again we have to differentiate that function. So here plus is there, so we can differentiate each and every term separately. So d by dx of ax, okay, I write here formula. I forgot that formula to write the d by dx of sin x is equal to cos x. In this step we used that formula, d by dx of sin x formula and d by dx of cos x formula. We applied these two formulas in this step. I forgot to write these two formulas. Okay, my children, understood that step. Now we differentiate that functions. Okay, my children, right. This is equal to cos of ax plus b just I wrote this cos of ax plus b first into cos of cx plus d. Okay, my children, into d by dx of ax plus here plus is there, so we can find the derivatives of these two terms separately. Understood this part, my dear children? Right. Minus into minus, what do you get here? Plus sin of ax plus b into sin of ax plus b minus into minus, what will you get here? Plus sin of ax plus b into sin of cx plus d. Understood this part, my dear children? Right. Into here also d by dx of cx plus d by dx of d. Here also we are finding the derivatives of each and every term separately. Understood that part, my dear children? Whole divided by cos square of cx plus d. Understood this step, my dear children? Right. Now come to the next step, my dear children. Cos of ax plus b I wrote this part as it is, cos of ax plus b into cos of cx plus d into, here in this brackets, d by dx of ax. Here a is a numerical coefficient, so we can write a into d by dx of x plus here d by dx of b. It is a constant. D by dx of any constant function is 0. Understood this part, my dear children? Right. Plus sine of ax plus b into sine of, I wrote this part as the sine of ax plus b into sine of cx plus d as it is into c into here c is a numerical coefficient, so we wrote d by dx c into d by dx of x, because c is a numerical coefficient, we can write it outside, plus d by dx of d, it is a constant term, so its derivative is 0, whole divided by cos square of, we write the denominator as it is. Understood this step, my dear children? Right. Because we use this formula, d by dx of a constant is equal to 0. Here also we used that formula. Here also we used the same formula, d by dx of constant equal to 0. Understood, my dear children? Right. This is equal to, we write this part as it is, cos of ax plus b into cos of cx plus d. We write this entire part as it is into a into d by dx of x. What is the d by dx of x value? 1. So I wrote here 1. Understood this part, my dear children? Right. Plus sine of ax plus b I wrote this entire part as it is, sine of ax plus b into sine of cx plus d into, here what will you get? C into d by dx of x. What is the d by dx of x value? 1. Okay, my dear children? Whole divided by cos square of cx plus d, because in this step we used this formula, d by dx of x is equal to 1. Understood this step, my dear children? Right. Next we write this a at the first, a into cos of ax plus b into cos of, after simplification you get a into cos of ax plus b into cos of cx plus d plus c. I am writing this numerical coefficient at the beginning of the term, c into sine of ax plus b into sine of cx plus d whole divided by cos square of cx plus d. Okay, my dear children? Understood? This is the derivative of the given function. Understood, my dear children? Right.